So I promise I don't have too many slides, so let's get started. I'm Marco from Evolution, and I'm part of a team called Frontend Core. And actually I want to start exactly from my team name, because I always thought it's a bit funny how in Evolution we have names with teams with crazy names like Unicorn, Ibu, my team. We have a team called 404, which never answers anything. That was a stupid joke. And then we have Frontend Core, which is a bit boring as a name, but quite straightforward because it tells you what we do, which is the core of the front end, whatever that means. So maybe today we will have a better idea once I'm done, so I know what to do tomorrow at work. And basically, as I kind of gave a hint, we work with some core features, components, and platform that the game developers use to build their games. And so that our goal is that Marco Zanellati can write amazing WebGL animation without having to worry about how to set up the React project, the linter, the pipelines, and all of that. Some numbers to make us look more impressive. We have a gigantic code base, mostly TypeScript. We have hundreds of contributors from a bit of all of Europe, 20 teams, game teams and non-game teams. We use trunk-based development, which means that we have one branch that we release daily, and we merge feature branches on it. Something like 50 merge every day. So we are all pretty busy with stuff. At the current state, our products are something around 150 games, and you have seen a little bit in the previous presentation what kind of games. We have live games with video streaming of dealers or game presenters in the studio, and we have first-person games with this first-person type of experience that the guys just explained. And basically what I would like to do, similarly as what Marco Zanellati did before, we would like to see how we got here. But my perspective is the one from the core side of things. I'm going to go a little bit back in time and see what are the sort of challenges we have faced and how some of the steps and missteps we did there. I put the name scalability or scaling in the title, a premise. Of course, front-end scalability is very different than back-end scalability. We don't really have to worry about the sudden surge of traffic like back-end does. So what I mean scaling is basically being able to grow in number of developers and in number of users, of course, and being able to output the same number and quality of games just as the company grows. Our products become more complex, we change technologies, and so on. So basically with all that long boring premise, let's go back in time a little bit. I lied when I said I have few slides. I have a lot. Also trigger warning, Internet Explorer, yes. This gives you the idea we're back in time. This is just a video to give you some impression of our games. This is a live Monopoly game from a few years ago. And what I want to take from this is, you can tell there is some components on top of the game. And these components, you have seen them maybe already in some previous videos. You have a chip stack to place bets, you have some settings to interact with the game, a chat, all sorts of components that you can use to build the game. These were built with React, and the idea at this point that starts growing is that all these games need to reuse these components, so clearly we're at somewhere that we should not repeat ourselves, so we should put things in a single place. In short, we start to build a game, what we can call a game library, which is going to take care of a bunch of stuff that the games should not do, or rather do alone. So in a single place, we build the backend WebSocket connection that we use, the component that now has reached something like 80 shared components, and also we build some shared layouts that basically gives to every game the same look and feel that you can tell. So you play different games, but you get some shared experience that you can then let's say appreciate. We also hide all of the boring B2B integration stuff that basically doesn't need to concern game developers. We just put it all in in a core library. So that said, at this point in time, we are using Redux. I'm guessing you guys are familiar. Can you just tell me? Can you raise your hand if you've used Redux? Or all right, more or less, you guys all know it. So I think they told me to not be too long here. So I think I will skip the Redux explanation. Let's assume you're all familiar. This is just some boilerplate Redux code that kind of shows you how it works. But since you're all familiar, we can skip that. But just to summarize, at this point in time, we are using Redux to build all of our business logic, which means that our games are using Redux to build their UI, and our core library is using Redux to allow to customize all of the features. So if we give a very short, summarized version of how we create a game, we expose from our core package, we expose a function that allows to create a Redux store. You can pass some customization via middleware's reducers, and then you receive back your store that you can use to open some pop-up as an example, or to, in general, interact with the core UI. So that said, everything works fine until, well, this is a JavaScript ecosystem. We love to make new stuff all the time, and suddenly there's a new kid in the block, and MobX is kind of taking, let's say, the scene. Who's familiar with MobX here? Okay, that's less. The guys from Evolution don't count. So that's not a lot, but that's interesting. So MobX has a very different paradigm than Redux. Redux is known for this sort of immutable state and unidirectional data flow, right? So you never change the state directly, you just dispatch an action, and then it's going to pass to the store. The store will reduce it into some new state, and the UI receives the new state. MobX just scratches all of that. It goes bidirectional data flow by using proxy, which I assume you're familiar. The JavaScript proxy that basically every time we make a call on a store, then it will proxy the new state, the notification that there's a new value to all the consumers. This is a whole different paradigm. My interest here is not to compare these two libraries. There's much more material online to do that. But what I want to say, basically, this is an example of how the same code from Redux before now would look in MobX. Simple observable value. Sort of the magic is in here, which just creates a proxy around this class. So to go back, what I want to say here is not really MobX is better than Redux. All of my colleagues will tell you about that. They are all passionate and hate Redux. But basically, my point here is that from the core standpoint, the challenge we faced is that our games are now being written in a whole different technology. But we have coupled our library to something that, as we have just seen, was very much Redux specific. So this posed a bit of a challenge for us. We achieved with something that is not exactly quantum physics. We just put a facade interface on top of it that kind of hides the Redux store inside it, and expose some vanilla JS JavaScript that games can use to interact with the core. So we kind of patched around that problem, but that took a toll on us because this is how the game would look now. It does look like now, instead of using Redux, as you can see, we just receive an instance core game that can be used to interact with the core. So yeah, to summarize, basically we built some abstraction around the Redux technology that we kind of deprecating, but it did come with a cost because we invested quite some time to migrate to a new solution and to abandon some previous technology. So what I would like to just share, some sort of lesson that I personally learned, was that coupling too much to a technology could be quite expensive and need to be done carefully. This is something that most likely all of you know very well, but it's a lesson that, let's say, we should keep in mind for the future. Of course, as I mentioned, wrapping something to be technology agnostic also can be expensive. So yeah, it's everything a trade-off. I don't have a magic solution for things, but this is sort of the challenge and lesson we learned. I put the React logo there because actually coupling heavily to React is some sort of topic that we are discussing now, because we have a lot of stuff built with React, but sometimes we wonder, do we really want to be using only React for this? A lot of games are not using React already, so this is a sort of sneak peek to the next, you will see me here in a year saying like, we did too much in React. So we'll see about that. All right, so let's move forward in our timeline of games. We have a little bit of a more modern Firefox browser here. You can see one of the first-person games. And just to give an idea of how our games are just growing. They're getting more complex, and there's more stuff happening. So from a core standpoint, what we need to do is to provide features that work for all games, which is not easy when you have a lot of different games. Something that we adopted that you have already heard today is this distinction between live and first-person games. And the idea is that live games are in the studio, you have a video stream from the dealer and the game presenter. First person, and you are playing, you are in charge of the game, and you play first person. This is something that made sense completely, still does, that our business still uses that distinction. So we used it, we adopted, we built a lot of stuff. We literally wrote code that you could summarize it: if live, do this, else do that. You will see what that coming, I think. Another abstraction that I want to share is how we built some features based on game phase sequence. Basically, when the dealer prepares to, has not dealt anything yet, then you can place a bet, right? So it's bets open, and then the dealer deals your card, or any other sort of dealing of the game phase, then it's bets closed, and you cannot bet anymore. That makes complete sense for most games. So we built a lot of logic on that. For example, you can interrupt the player before he places bets, but you should not interrupt the player from looking at the game while the bets are closed. So we built things on top of that. And guess what? All of that didn't make sense anymore at some point, because as you have seen before, we have live slots. We have a game that is played with a video stream of a dealer, but our business is very creative and it comes up with all sorts of things. And now we have a slot game inside, so we need a video, but in a game that is also first person in parts. At the same time, our open bets, closed bet abstraction failed because some other game now have multiple betting phase. It means that while I'm looking at the closed bets phase, I can bet already for the next stage. So this is just a sort of lesson that we learned here, is that our abstraction really didn't scale, and it has some technical debt. And what I learned from this personally was that we stuck to something that didn't make sense anymore as our product changed, and we stuck we made our product fit into software that didn't make sense anymore. So what I kind of learned from here is that we should rather continuously rethinking our design choices and think whether the current the software we have written still makes sense for the product we have. So continuously rethink whether what you're doing still makes sense, or you should rather pivot to some different solution. And by the way, yeah, we are getting rid of all of our if-else statements and similar logic. Better Chrome, more games. This is sort of just a panoramic of all of the many more games we developed, of all kind of things. And at this point in time, we have something that we can call multi-repo approach. Our games are stored in the different repositories, and the core package, the library, is in a separate repo itself. So we publish it with versions, and every game in their own repository upgrades to the core. This works, but it comes with a lot of trade-offs. It comes with the fact that you cannot atomically change all the games in one single go, because you need to upgrade every single repository separately. And you need to publish semantic versioning of your library, and that's not an easy thing to do, because you need to realize what exactly is your new upgrade. Is it a patch, a major or minor version? And ultimately, you also have dependency hell, let's say, because you need to now deal with the repositories that have different versions of React, each of them, for example. So what we pivoted to in this time was a monorepo approach, which is basically, you might be familiar, where you have all of your projects inside a single repository, and they all share the same code base. This comes with a lot of good stuff, which is semantic versioning is not a problem anymore. We can have consistency of the games immediately in one single go. And we can do that in an atomic way. So basically, we can also upgrade all of our games to TypeScript latest version without game developers even caring about that. We have a single version of TypeScript and similar dependencies, so we don't have that dependency hell I mentioned. And something I really like is that we have visibility. We can see other people's code. We have a problem, you can go in another package, see how it was done. And of course, all of the stuff like linter, project setup, all of that, what I mentioned, is coming out of the box. Of course, now we have other problems. We have a solution, but other new problems. Being in a single repository could mean that you can just import everything from anywhere, right? And that means that your boundaries might be get very messy and clear. That's the spaghetti picture. And also, when you merge something, it might just trigger validation of the whole repository because you don't really know what you need to revalidate. So that's going to mean a much higher load on your CI because now you're validating all the time. So how we solved some of these problems was by using TypeScript project references, which is a way that TypeScript gives you to represent all of your code in a repository as different projects. So it's not one single TypeScript project, it's many projects that are composite projects that reference each other, depending on how you organize your dependency graph. So in this example, we have a core package, which is referenced by other core sub-packages and game packages themselves. So you can follow the graph this way, but you cannot really do circular dependencies or reference any shared code from the game or cross-reference game code from each other. So this gives us a much better, clean access control to the code. By the way, I didn't know about the ravioli code, that's a thing apparently. That means that everything is packaged, and I like that, so I needed to put it there. And also, beside the, let's say, better access control and packaging of code, we have compilation speed, because TypeScript just will compile whatever you reference in your project. So if you go back to our previous example, actually even before, we see we split the compilation of the game into source and test. So when you write your source code, you're not recompiling test code at all. So to move forward to the next problem, right? Because we still are in a single repository. We still are dealing with one single code base that needs to be released together. So there's still a bunch of issues. For example, Git itself is not really meant to handle such large repo, and there's a lot of optimization that we can do. So now, for example, we are targeting to use sparse checkouts. That basically is a way for you to only check out what you need. So the game package would only check out their code without needing to check out every other game code until it's needed. That's how sparse checkout works. We use GitLFS for large file assets. And we use to save, let's say, our ass when merging a lot of merge requests together, which can cause a lot of trouble in race conditions. We use GitLab merge trains. Basically, it schedules all of your, once a lot of developers put things in the queue to be merged, it schedules the queue in a way that guarantees that your main branch is going to be green and not fail because a race condition might cause something conflicting to be merged. So it will revalidate every single merge request together and make sure that as a batch together they can be merged. If one causes conflicts, it will be taken out of the queue and you will not be able to merge. So everyone else will merge, but you will not. This is a feature provided by GitLab. There's a similar thing on GitHub, but it has been a success for us. To go forward with all the good stuff for monorepo, we have the bad stuff. In this case, we have the fact that atomic changes are still a little bit expensive, meaning that as we have more games, and we do, we have dozens more every time. It means dozens more updates that need to be done. Let's say you change an API, you need to now update all of the other games. As I mentioned, we try to use trunk-based development, meaning we try to use the proper approach, which should be a short-lived feature branch, so you don't cause yourself too many conflicts, and you can merge more frequently. and use feature flags. But in short, from the core standpoint, if you look at let's say at the future, as let's say assume we have dozens and dozens more games every year, what we need to do is to be able to not couple ourselves too much to the game code, so we don't really have to update too much code. That's also kind of improves, should improve our design system. Finally, I think we just need to reduce the pipeline, the effort on the pipeline, which is something that is affecting a little bit of our core teams, because game teams want to revalidate all of their games every time something from core changes. But of course, that puts an effort when you are on the other core side, because you will every time you change something in the core, you will validate every single game. So these are sort of the challenges that we are facing at this point regarding monorepo, but I think it has been definitely a success for us in scaling and let's say growing the number of games so far. Just make sure that if you adopt monorepo, you have a proper constraint in place so that you don't put too much effort on your CI. You know that the packages are properly split. For example, the time split project references. More challenges that I didn't mention that we have. We have the issue that our core library might have a lot of good stuff, but the game teams don't even know about it, so we need to kind of provide that sort of discoverability of the feature. It was mentioned, I think, at the beginning of today of a design system, which is something that also we are working on. Additional trouble, let's say, at a large scale is making sense of observability. We use Sentry and other logging systems, but the volume is just so high that it's hard to make sense of it sometimes. Other problem that luckily only core teams face is integrating other games. Now Evolution is integrating other companies, and now you have a whole different game, a whole different stack that you now need to integrate with the same feature, and of course you need to do it today. Other stuff that we face are code reviews. It gets increasingly hard, let's say, to get timely reviews once you affect many teams. We built some sort of custom script there that randomizes the assignment of people to code review so that everyone kind of shares the load, and also there's some accountability that everyone learns the product. These are just some random stuff that I'm throwing at you to maybe make you think that joining core would be interesting. But if not, you can join the guys with WebGL stuff. In any case, if you're interested, we are hiring. That was it. I think I was quick enough. I don't see a sign. Yeah? Okay, so that was it. Any question?
So,
yeah.
you show stuff or the white one?
The pink one. Actually, I'm sorry to say, but I like the Lithuanian one better. I should have said that later. It's good. See you at the festival this weekend, by the way.
Yeah. So, do you have questions?
You just earned a couple of red cards.
Yeah.
Pink cards.
Yes. Yeah, sorry.
Yeah, so you mentioned you have monorepo, right?
Yeah.
And so, just interesting, how you're dealing with a linter. So, for example, you have linter on the whole project, right?
Mm-hmm.
And you have like thousands of games.
Yeah.
For example, you need to introduce new rule to the linter.
Yeah.
But then you run the pipeline, and every 1,000 games will be affected by the linter. How you will?
Yeah. So the approach we had is that even though ESLint recently moved to flat config, basically they have a single config. They want you to use a flat config. We still we have a previous approach of having every package its own linter configuration, and we leverage that to basically enable a new rule with warn level, and then re-enable it per package, basically creating tickets for every game team to update their code and enable and toggle on the rule on their package to error, so that That's one way we progressively migrate. Of course, as I mentioned, doing it atomically for the whole repo is best, but if you have 10,000 files to update, then you basically move that to the game teams.
Thank you.
Yeah, and you do that in iteration. Yeah. Yeah. Any other